Alright, okay, so in this video I'm going to demonstrate how to take a file that has been exported from Autocad into an IGES format, which is compatible with Bobcad 20, and manipulate it so that you can cut a template or base or some sort of a file from that on the CNC multi-cutter router. First thing you want to do is open up Bobcad, and you want to file, open, and go to the IGES file that you saved, which in this case is SP Twin PA 157 blah blah blah. Open it, import curves and solids. Now when I exported it from AutoCAD, I deleted all the various dimensions and stuff on it, but I forgot this one little thing here, so I'm just going to get rid of that. And one thing that tends to happen a lot of times when you're importing into Bobcad is it reads it files in as inches, so that they're way too big. They're 25 times too big because there's roughly 25.4 millimeters in an inch. So the very first thing you need to do is scale this drawing down so it's the right size. Now if you in a calculator go 1 divided by 25.4, so 1 inch divided by 25.4 millimeters gives you a decimal 0.3937 blah 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 blah. I'm going to copy that number, so that's how much I need to scale down this file. I'm going to then click drag this whole file so it's everything in the file is selected, and I'm also going to rotate it counterclockwise. So I'm going to choose the rotate command because it also can scale at the same time, and I can kill two birds with one stone. So I'm going to rotate it. In the scale dialog, I'm going to paste in, Control V to paste it in, or edit, right click, edit, paste. 0.39, that number from the calculator is there. And then I want to rotate this file around the z-axis, so it's going to pivot this way around the z-axis 90 degrees, and that'll get this file oriented the way it needs to be for the CNC. If you think of the right here, this axis is the left lower corner of the table of the CNC looking down, and so we're looking at the table roughly where I'm drawing this rectangle will be where the CNC router table is. So I'm going to, first of all, I'm going to rotate this. Now you'll notice it's scaled way down here. If you hit the Z key in Bobcad, it'll zoom in to the extents of the drawing. And then I'm going to drag it over here. In order to translate this, since it's all highlighted red still, it's still selected. So I'm going to go edit, or sorry, change, translate. And I'm going to take the scale out. I want it to be 1 now. We don't want to scale it down again, so I'm going to change the scale to 1. And then I'm going to hit drag instead of, and that just allows me to literally move my mouse. And you can see as I move the mouse along, it sort of shows where the file is. I'm going to move it roughly 1 inch from the bottom of the CNC router and 1 inch from the left of the CNC router looking down. So I'm going to click, right click here and just let go, and then click off of it with the right mouse button, and that just deselects it. Now if we zoom in, you hit the V key to zoom in and it gives you the little magnifying glass. And if we just highlight briefly over one of these points, you can see, if you look in there, the Y is about 34.6 millimeters from the y-axis. So we want to move that down to maybe 20 millimeters or so. And same thing with the left side of it, it's at about 34. So what we want to do is translate this file approximately 14 millimeters this to the left and approximately 12 millimeters down. So I'm going to hit the Z key to zoom out, and then I'm going to just drag and select the whole file, and then go change, translate. Now this time we still want 1 in there. I'm going to move it on the x-axis -12 to get us roughly 20 from the x-axis line here, and then we want to go -14 to get it roughly in position. So now if we zoom in again here on the tail, we're approximately 20 centimeters from there, and if we look here, no, we're still 25, so I need to move this another 5. Change, translate, -5, and we don't need to do anything with the Y, so we're going to change that to 0, hit OK. That'll move it a bit to the left. And so now this is approximately 20 millimeters from the edge of the table, and this is 20 millimeters approximately from the edge of the bottom of the table. Now For this particular file, what we want to do is cut a template or a base out of it. So we just basically need to select this geometry and cut it out. Now, Bobcat has the ability, you could either export this file at this point. There's two ways to do it, I guess. You can export the file at this point and put it in SheetCam, which we have a video on how to do that. That's a very easy way to cut them out. Or you can generate the code in Bobcat. I'll quickly do both here so you can see them. I'm going to just delete these boxes out of here for now because they're not necessary for this particular step. So to export this out of this program, you want to just go Save As, name it as a DXF file, and we'll call this template. Oops, I got caps lock on there. Template. So we know what this file is, and it's a DXF format that'll import into SheetCam, and then it's very easy to use the CAM elements of that program to cut it out and do that. That's demonstrated in another video on the website. Now, if you want to use the BobcatCam package, there's a little button up here called Special NC Cam, and if we insert an NC command into the code, what happens is we want to select Mach 3 Marco. That's the post processor we want to use. Don't select any of these other ones. We want to use Mach 3 because that's what used on the router. Hit OK, and you see on the right hand side a new dialog opens up, and it sort of squeezes over the other one on the left here. I'm going to click up here. I'm going to click on the top here and hit the Z key once, and that just zooms the file down so I can see all the geometry, since when it was squished over, it scaled a little bit. And then what we want to do to select this geometry, there's a neat little wizard in the CAM side of the program here under the Machine menu. You go Machine, Profile, and that then gets that command active, and then we go over to the geometry, and I'm going to select a point here on the bottom of the board where the router is going to drop in and start cutting. I'm going to click that point, and right now you'll see if I move to the left, the arrow change, or left or the right, the arrow changes either to the left or the right. I want to move to the right and click again, and you can see this arrow is now pointed this way, which means that when I select the rest of this geometry, it's going to go that direction. If I clicked and selected over here, the arrow will be pointing that way, and the router will select this way, which is clockwise, and that is going against the way you should normally cut with a router. Normally you want to cut with a router from left to right, so we want the arrow going this way. So now that I've got that selected, I haven't done anything except selected it, clicked off the thing. Now I hit the F3 key on my keyboard. On your laptop, for some of the CNC routers, you have to hold down the function key and hit F3 because the small keyboards on there don't have a separate row of keys for the function keys. But anyways, you want to hit F3, and you'll see how that, when I hit F3, it selected all the points in the geometry all the way around until it came back to the one where we started, and then it opened up a new dialog box that says, do you want to pick your own lead in and lead out point? No, we don't, because we're just going to have the router come in from the zero axis. It's going to move over here right to where it wants to start. It's going to drop down and then just start cutting. A lead in, lead out point would start cutting before it hits the template and then move into the material, which we're not going to do in this case. So I'm going to select no here. Then a dialog box opens in the wizard that has rapid plane, material top, and cutting depth. Now, this particular template we're cutting out of 1-inch MDF, which is 25.4 millimeters thick. And so when we move the router above the material, I usually like to move it maybe 20 or so centimeters above, or 20 or so millimeters above the material, so that the bit's not even close to it when it's moving. So I'm going to just change this to 50, and then the material top is 25.4 because it's 1 inch thick, and 25.4 millimeters equals 1 inch. Now the cutting depth, this is how deep down through the material you want to cut. If we wanted to cut right through it, we would put 25.4. Or sorry, if we want to cut right down to the table, we'll go right down to 0. But I usually like to cut almost right through it because that doesn't run as much risk of the bit damaging the tabletop. So what I usually do is I put a number like 0.2 millimeters. So it's going to go all the way through the material and then stop just 0.2 millimeters shy of the table, which is just this tiny little paper thin layer that is very easy to just sand off of your template or whatever when you're doing it. And Then the next thing you need to select is depth of cut. Because this material is 1 inch thick, you don't want to cut through it in one pass. We want to cut through maybe 4 millimeters, or let's see, we'll do 25.4. Quarter inch is about 6.35 per pass, so we'll go 6.5 millimeters per pass, and that way this will cut through 6.5 millimeters down, another 6.5 millimeters down, and it'll go through this template in 4 passes. Because the bit diameter we have is only 3/8 of an inch, if you try and cut through 1 inch material, it really grabs in the material and it causes the cut to be a little bit uneven and a lot of bit chatter. So it's better if you cut it in a few passes. Okay, then the feed rate, we'll do something like 4,500 millimeters per minute. The plunge, which is how fast it goes down into the material, I'm going to 250 millimeters per minute, and I'm going to hit next. Now, this is the tricky part, or the cool part of this wizard, is it does automatic tool offsetting, so it can cut either on the inside or the outside of your line without you having to do any manual calculations for that. What you do in this box is tell it what the diameter of your bit is, and we've got a 3/8 inch bit in the machine, or 9.525 millimeter diameter. We want to use automatic tool compensation, and we want to compensate to the right of the material, because when the router is going this way, we want the bit to cut on this outside of the material to the right, so that it leaves us exactly the shape that the CAD line is here on our template. So we want to compensate to the right. If we wanted to cut on the inside of this, we would switch this, and if you watch on this side, when I click left, the red line jumps to the inside of the line, and it would cut, you know, the exact opposite, so that the you know, it's cutting on the inside of that line. But we want it to the right, and then we hit OK, and it very quickly generates all the code to cut this template. Now, at this point, I always like to do a quick check to see that there's no weird errors in this file. And what you can do to do that is go Edit, select all geometry, and it highlights all this geometry, and then you go Edit again, Geometry from NC. And what that does, it takes all this data and puts the geometry it's going to cut back into the drawing. And sometimes you can see that for some reason something in our code isn't going to work, and it'll give us some little errors. So I'm going to do that. But when I did it, you can't see anything different here. Sometimes you get these weird little circles at transition points, or a line, you know, it just doesn't look right. But this geometry looks exactly the same, which means our file is good to go and cut and should not give us any errors. Or it's a good check. It's not perfect, but it's a very good way to check it. Now I'm going to click on this and go Control Z on this left side just to undo that last step we did, because we don't want that line. In fact, I'm going to undo the other step here. And that gets rid of the outside line, and we've just got that shape file that we originally started with. You see that if I'm doing it on the left side, it doesn't affect what's going on the right, where we've still got all our code. Now what we want to do is save this code as save copy as, and we want to name it something so we know what it is. And we're going to call this template, or what's the board? The SP twin paw 157 template cutting. Now we don't necessarily have to call it cutting file, because the extension file tap indicates it's going to be cutting file, so we could just call it SP157 twin paw template, and it would, you know, the file will give it away. But when you're just quickly looking through your computer, it's having the appendix cutting file just makes it really easy for you to know what this file is and not get confused. So if I save that, now we've got a file that you could just load right into Mach 3, and it will cut the this template shape.